Okay, ladies and gentlemen, we are going to take some notes over Chapter 9, which is on chemical reactions. Okay, in Chapter 7 and Chapter 8, we learned how to write the chemical formulas and to name chemical compounds, which is basically like learning how to write the words of a sentence. In this chapter, we learn about reactions and equations, which is taking those words that we learned how to write in the last two chapters and make a sentence. Okay, so in section 1, we talk about reactions and equations. Okay, the objectives for section 1: recognize evidence of chemical change, represent chemical reactions with equations, and balancing chemical equations. For our review vocabulary, we have chemical change, a process involving one or more substances changing into a new substance. New vocabulary we're going to look at: chemical reaction, reactant, product, chemical equation, and coefficient. The main idea behind this section, is chemical reactions are represented by balanced chemical equations. Okay, the process in which one or more substances are rearranged to form different substances is called a chemical reaction. Everybody takes chemistry, so we can play with these chemical reactions, so let's learn a little more about them. Okay, from the labs that we've done so far, what evidence have you guys seen of a chemical reaction? Well, number one, we've seen a change in temperature. We have seen things change colors. We have smelled things. We have seen gas or bubbles form. Those are all evidence that a chemical reaction has occurred. Okay? Chemists use statements called equations to represent chemical reactions. Okay? So the reactants are always the starting substances of a chemical reaction, and usually they are on the left-hand side of the equal sign. Products, on the other hand, are the things that are formed during the chemical reaction, okay, which are usually on the right-hand side of the equal sign. Okay, this table, which is also in your book, summarizes the symbols that you're going to need to know and understand when we write chemical reactions. Okay, the pluses separates two or more reactants. The arrow sign either produces or yields. When you have a double arrow sign, that means that the reaction can go both directions. When you have the S, that means that you have a solid. L means a liquid. G means a gas, and AQ means that it's in water or an aqueous state. Okay, in equations, you read it as the words just like you would read a sentence. So aluminum, okay, the S means that it is a solid. So aluminum plus bromine yields aluminum bromide. Okay, you can also read it as aluminum, which is a solid, plus bromine, which is a liquid, yields or produces aluminum bromide, which is a solid. Okay, so the skeleton equation that you're going to see lots, okay, a lot of times as we're doing this, skeleton equations use symbols and formulas to represent the reactants. Reactants are always on the left side of the equal sign or the yield sign, and the products are always on the right-hand side. Okay, so you're going to have element plus element yields a compound. Okay. Okay, chemical equation is a statement that uses chemical formulas to show the identities and relative amounts of a substance involved in a chemical reaction. Okay, so just as if we had to balance the elements together for their oxidation states, remember those had to equal to 0. When we were making a compound, we need to do the same thing. We need to balance out the compounds, the elements in the compound, to equal the product. Okay, so if you look at aluminum plus bromine, you can see that we have one aluminum present on this in the product plus 2 bromines. Okay, however, over in the product, we have 1 aluminum and 3 bromines. Okay, we must balance out the reactants with the products. That means that on this side we have 2 bromines, and on this side we have 3 bromines, which means our equation is not balanced. Okay, so let's figure out how to balance it. Okay, this figure shows the balanced equation for the reaction between aluminum and bromine. Okay, you can see how they've put numbers in front of the reactants and in front of the product. These are called coefficients, and we are going to multiply the coefficient by the subscript. I just lost my cursor again. Oop, let me go back. Okay, so we are going to take 2 times 1, because there is nothing written here, so 2 times 1 gives us 1 aluminum. Okay, here goes my cursor again. 2 times 3 is going to give us 6 bromines. Okay, that's how many we have in the product, in the reactants. Now we go over to the products to see what we have. We have another coefficient, 2. Aluminum does not have a subscript, so 2 times 1, okay, gives us 2. So we have 2 aluminums in the product, and we have 2 aluminums in the reactant. The bromines, we have 6 bromines in the product, and we have 2 times 3 gives us 6 bromines in the product. So we are now balanced. You cannot change the subscripts, and like I told you guys before, you're going to try and do it once or twice as you're practicing through here. It's so easy to do. You cannot change these subscripts. Okay, the only thing that you can change when you balance an equation are these coefficients, the numbers in the front. And sometimes you have to go back and forth and count 2 or 3 times until you get it balanced. A coefficient in a chemical reaction is the number written in front of the reactant or the product, describing the lowest whole number ratio of the amounts of all the reactants and products. Okay, so here are your steps for balancing the equation. Okay, I'm going to let you guys read through those. You're going to get lots of practice doing this. Okay, oops, went too fast. Okay, the most fundamental law in chemistry is the law of conservation of mass. From physical science, from earth science, you've learned about the law of conservation. Okay, mass or matter cannot be created or destroyed. It just changes states. It just changes where it's located. Okay, so the same thing with the mass. You have to have the same amount of mass that you start in the equation, with, which is the reactants, okay, has to equal the products. There has to be the same amount. The law of conservation of mass. Okay, balancing equation shows this law. Okay, so here is a very good diagram to help you through balancing chemical equations. Okay, so step 1, write out the skeleton chemical equation like we talked about before. Okay, all the element 1 plus element 2 yields the product. Okay, so remember the reactants are on the left-hand side of the arrow that produces or yields, and the products are on the right-hand side. Okay, so now for step 2 and 3, you count the atoms. Count the atoms that are on the reactant side, count the atoms that are on the product side. Okay, and I will write them down. Okay, it's still sometimes hard for me to visualize without writing things down and cross the numbers out, so go ahead and write them down. Number 4, okay, you need to adjust the coefficients. That is the only number you can change, is that number in front, okay, that coefficient. So every time you change a coefficient on one side, on the reactant side, it is going to have to change on the product side. So you have to balance back and forth. Okay, patience game and you'll get it. Okay, so step 5. Okay, reduce the coefficients to the lowest possible ratio. So if you have a 2, a 5, and a 10, you could reduce your coefficients down to 1, 2, and 5. Make sure that they are in the lowest common denominator, if you want to put it that way. And then go back and check your work. Okay, which of the following is not a chemical reaction? A piece of wood burning, a car resting, an ice cube melting into water, or litmus paper turning blue? And I'm not going to give you the answer. What do you think? And then we'll let the bouncing ball tell us. Answer is an ice cube melting. Because remember, a chemical reaction has to have, what is the definition of a chemical property? Okay, there has to be some kind of change, a new product made. Okay, so with wood, we had ash and gas. We have this rust here. Litmus paper, that literally is a chemical that is changing in there. When we have ice cube melting, it is just a physical change, a state of matter. Okay, the next question. What is the coefficient of bromine in the equation 2 aluminum plus 3 bromine, yields 2 aluminum bromide? What is the coefficient of bromine? So your answer is right here. So let's see if the bouncing ball agrees. And yay, it does. Okay. All right, so you guys will be going to Hippocampus to take notes, to listen to that professor talk about how to balance equations, and then you're going to get some practice with that. Okay, we'll see you guys later.